Let's begin. Today's December 28th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 2, 7, 8, 18, and 21. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. Criteria card A takes a look at our first digit, the triangle digit, and the Turing machine will be comparing it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B takes a look at our last digit, the circle digit, and the Turing machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at the 3-digit solution, and the Turing machine will let us know how many ones there are. Are there no ones? Is there a single one? Perhaps 2? Maybe even all 3 are 1. Criteria card D will take a look at our 3 digits, triangle, square, and circle, add them up, and the Turing machine will let us know whether if the sum total is an even quantity or an odd quantity. And finally, criteria card E, again, we'll take a look at our 3-digit solution, except this time, the Turing machine will let us know a little bit about the structure of our solution. Specifically, there are 2 scenarios. One where the solution does have a pair, as in the example 131, or alternatively, there is no pair, but there are 2 cases. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card B. Okay, so the Turing machine does not approve of my choice in circle. I did pick an even 4, but since the Turing machine does not approve of that, it's actually informing us that circle should actually be odd. So let's go ahead and type that up in our notes in section B. And we'll say that circle is an odd digit. And since it is odd, let's go ahead and cross out the 2 evens. Okay, so the next thing I'd like to test is criteria card D. Okay, so the Turing machine again does not approve of my choice. In criteria card D, we are adding up the 3 digits. Well, let's go ahead and do that in our proposal. So that is 3 plus 1 is 4, 4 plus 4 is 8. 8 is an even quantity, but since the Turing machine does not agree with that, it's informing us that the sum total should actually be odd. So let's go ahead and type that up in our notes in section D. And again, we'll say that triangle plus square plus circle should be an odd quantity. And what does that inform us of? Well, remember we did establish that circle itself is odd, and if we want the sum total to remain odd, there are actually 2 scenarios. One where, in either case, both triangle and square have to be of the same type, meaning that they either have to be both even or both odd. And that's because whenever you add up 2 of the same type, whether they're even or odd, that sum thus far would be an even quantity. So even plus even is even, odd plus odd is also even, but then we would add to it that odd digit in circle, and then that would establish a sum total that is odd. So that basically means that we're looking at either an even, odd solution or an all odd solution. Okay. Well, I'm sort of now focusing between criteria cards C and E. And I'm just wondering if perhaps they are both even. Well, I guess it could also be both odd. Maybe there is a pair of digits. So let's go ahead and test criteria card E. Okay, so the Turing Machine does approve of my proposal 314, but notice that 314 has no pairs. They are all distinct, and the Turing Machine approves of that. So that means that our solution indeed has no pairs. So let's go ahead and type that up in our notes for section E, and we'll say that the solution has no pairs. Okay. Well, that really didn't clear things up. And I don't think we can cross out anything else. Okay, well, that does conclude this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing that first digit, that triangle digit, to the number 3. And we did not query criteria card C, establishing how many ones there are. So let's see. Well, if there are no pairs, I don't think we can have 3 ones. Can we have 3 ones? If there are no pairs. Well, we do have 2 possibilities. They're all different or all the same. What would that mean if they were all the same? Is there a way to exclude that? Or are they all different? Well, let's think about it this way. We know we can't have 2 ones because that would be a pair. Okay. But we really haven't eliminated the no one, a single one, or 3 ones. Well, let's see. Yeah, so you can't have 3 ones because if you had 3 ones, you know triangle would be less than 3. Okay, so you can't have 3 ones. You can't have 2 ones because that would be a pair. And so it does now fall under, are there no ones or a single one? So let's see. So remember, we are looking at potentially 2 evens and an odd or an all odd. So if it is odd, it seems to be that all the digits would be distinct. And if you have 2 evens, well, you could either have the 1 or not. So what could we? Well, let's see. If there are no ones, then we'd be looking at 2 through 5 in both triangle and square. And then you'd have 3, 5 to pick from in circle. So what would that look like? 3 and 5. There really isn't, we're not really even comparing 3 and 5. So how would you pick between them. That's unusual. How would you pick? Somehow we have to force, well, unless somehow it defaults to 1. So it could be that we're looking at a single 1. We force it to be a 1. So there is a single 1, and then how would you pick your square, your triangle and square values? Well, we could have, I guess we could force triangle to be a 3. And if they're all distinct, somehow we have to force, again, circle to be 1. So how would you force square? In fact, other than criteria card D, there is no mention of square. So again, you're almost wanting to force square to be a value. So how would you distinguish between 315 and 351? You're almost having to force both square and circle. And I could see how you could do one but not the other. How would you choose? How would you distinguish? Okay, so if it's not 3, but I still want to somehow force circle to be 1, well, what about if they're both even? How would you pick? Well, if it's not 3, and if it's going to be even, it's either going to be 2 or 4. But if it's greater than 3, then again, how would you pick between 4 and 5? So somehow, maybe we can force triangle to be a 2. Because there's only a single 1. And if there's a single 1, well, could it be triangle or square? Well, if there's a single 1 and there are no pairs, yeah, it seems like you'd be forced to have to pick triangle 2. 1. Yeah, because if triangle is 1, how would you again pick between 3 and 5? How would you distinguish them? There's like no ordering. So yeah, so I think maybe if triangle is less than 3 and there's only a single 1, maybe that's how you force circle to be 1, triangle is 2, and that forces square to be 4. So 2, 4, 1. Let's give it a try. 2, 4, 1. And just to make sure, is our last digit odd? Yes, it's 1. Is the sum odd? Yeah, 6 and 1, 7, odd. And no pairs. Okay, let's give that a try. Okay, so now between criteria cards A and C, is there one that would benefit us the most, where we could maybe deduce the other? Well, I guess before you can test A, you have to know that there's only a 1. So let's go ahead and test criteria card C. Oh, the Turing Machine does not approve of there being a 1. So in fact, there shouldn't be any at all. Okay, well, let's go ahead and type that up, and we'll say that the solution has no 1 digit. Okay, well, let's cross out the 1 in each. Okay, so there are no 1s, and Okay, so there are no ones. So if you did have two evens, 2 and 4, again, how would you then now pick what circle would be? How would you pick between 3 and 5? That doesn't make any sense at all. Okay, well, let's go ahead and test criteria card A. Okay, so the Turing Machine does not approve of my 2. 2 is less than 3. That is wrong. Okay, so that means that triangle has to be either equal to or be greater than 3. Okay, this is quite confusing now. Triangle is either equal to or is greater than 3. Okay, so what does that tell us? So it can't be a 2. So either you have 3 or something bigger than 3. Well, okay, so if it is to be an, yes, I don't believe it's going to be an all even solution. It can't be 4. It can't be 4, 4, because that would be a pair, and 4, 2, although that's okay. Again, we go back to how do you pick between 3 and 5? So can I cross out all of the evens out? 4, 2, 3, and 5 would be ambiguous. You can't tell them apart based on the criteria cards. And 4, 4 is invalid because that would establish a pair. Okay. So it looks like there can't be any evens yet. We're supposed to have no pairs. Oh, look at that. So no pairs. We could have a 3-digit, a number that repeats 3 times. So it falls to either being all 3s or all 5s. Is that even odd? Yeah, that would be odd. There are no 1s. The sum total would be odd. And yeah, technically there are no pairs. Okay. Well, unfortunately, there's no use in testing B, D, and E because we sort of already established what all of those are. So we would have to go to a third round. And so it just falls to whether it's a 3 or not. Well, it's a 50-50. And you already have triangle equal 3. Well, let's give that a try. 3, 3, 3. Okay, yeah, it's a 50-50, and all we have to do, yeah, at this point, it's just testing criteria card A. Okay, so A. Okay, so triangle is equal to 3, so let's go ahead and cross out here in our notes. So, yeah, A is equal to 3, so that means, triangle is equal to 3. And so, because we can't have a pair, right? We can't have a pair, so it can't be 3, 5, 5, or 3, 5, 3 for that matter. So, yeah, that's 3. If this is a 5, it wouldn't be 3 and then 5. So it doesn't seem like square could be a 5. Again, we're forcing. Yeah, it seems like I mentioned earlier, we're having to force square, and circle. And we're having to force them to be both 3s based on all of the criteria cards, and their conditions. That, so it seems like the solution is 333. Okay, well, I think we've reviewed it enough. Let's go verify whether 333 is correct. 333. Okay. Wow, okay, yeah, it's 333. Okay, so how do we do versus a Turing machine? Well, it is a 5 criteria card puzzle, and we did it in 6. Well, let's see how we did. So in the first round, we did BDE, with E being the only correct one. In the second round, we did the remaining 2, and we were somewhat hamstrung. We really couldn't test a third criteria card in round 2, so we had to go to round 3. So, and we tested A again. So A was the only one we did twice. So B, D in the first round. So B and D were both incorrect. E was correct. In the second round, we did the remaining 2, both incorrect. That proposal did not work out. Had to go to a third round where, we just got lucky with a 50-50. So how do we do? Oh, wow, we both did it in 6 questions, but because we had to go to a third round, we end up losing. So it's, I guess that's the tiebreaker. The tiebreaker is the number of rounds. So even though we were as efficient as we could be from a question perspective, we lost out on the rounds. So, well, how did you do? Did you actually get the win? What criteria cards did you choose? I'm just trying to sort out what could we have done differently. Could we have delayed either B, D, and E to the second round? Because it seemed like since A, we had to do it twice. If we would have played in the first round, well, I guess we would have gotten it correct, which would have been somewhat helpful, but it's always, it's a risk in my opinion, but this time the risk would have paid off. But how did you solve it? What criteria cards did you choose? And did you see anything that you'd like to share? Some, like I call a aha moment, something interesting in your choice. Please add those thoughts to the comments. If you like the video, please do give it a thumbs up. And of course, don't forget to hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.